be critical numbers. Critical numbers. You know that there are two places that you're going to collect these critical numbers. They are going to be the solution of this equation if the function is differentiable, f prime of x equal to 0. This is where the tangent line is going to be horizontal, or where the tangent line is vertical. F prime of x does not exist. Okay, you check these two positions. The solution of this equation or the solution that you got over here, they are going to be your critical numbers. Okay, for this question, we are not going to give you a polynomial because we checked the polynomial in the other parts. So it may be a radical function or the rational functions, okay? And you have both of them over here. So we have the part one. Okay, part one, the function is f of x is equal to the 5. Okay, 5 plus x to the 1, 7. Okay, is the rational power is the same as the radical function. First thing to do for the critical numbers, you must have the domain of the function, okay? Because you must make sure that these numbers are going to be in the domain. So this function is a radical function. If you like, you can change it so that you can see it. It's f of x, 7 roots of 5 plus x. Okay, it's a radical function. So the index of the radical 7 is odd. You know that when we have the odd index, domain of the function is going to be all real numbers. So the index of this radical 7 is odd. So that would imply that the domain of this function is negative infinity and positive infinity. This is going to be your first step, domain of the function. Any question? So that's the case. Now we differentiate. We take it as this function and we differentiate it. So f of x equal to the 5 plus x to 1, 7. If you want to differentiate it, you know that you have to use the chain rule because this is of the form of u to the 1, 7. Okay, u to the 1, 7, you differentiate it. You know that you bring the power down, it's going to be 1, 7. Okay, u to the 1, 7 minus 1, 1 minus 7 would be negative 6, 7 times the u prime. You know, it's nice to remind yourself that this is going to be your formula if you like. So now we copy the formula. F prime of x is going to be equal to the 1, 7. Okay, 1, 7, 5 plus x to the what? To the negative 6, 7 times u prime. U prime derivative of the inside. Derivative of inside, derivative of 5 is 0, and derivative of x is 1. Okay, so you simplify it. F prime of x is going to be simply 1, 7 times 5 plus x to the negative 6, 7. Since you want to let it equal to the 0, you have to rewrite it with a positive exponent. So it's going to be equal to, we get the 1 on the top, and the 7 times 5 plus x to the 6, 7. This is going to be your f prime. Any question? Now we let it equal to the 0. If you let it equal to the 0, so we already talked about it. Only the top would be 0. Okay, so that would imply that 1 is equal to the 0, which is impossible. So we get nothing. We get nothing from the f prime of x equal to the 0. But we already talked about it. It's not the case that you are going to tell us that there is no critical numbers. Remember the definition of the critical numbers? Either f prime of x equal to 0 or f prime of x does not exist. Now, since this is a rational function, the f prime or this function is undefined when the denominator is 0. So you check to see for which value of x denominator would be 0. Denominator is 5 plus x. So if you replace x by negative 5, denominator would be 0, and the f prime of negative 5 is going to be undefined. So in that case, you have a sharp corner or you have a vertical tangent line. Now, the point is, this -5 is in the domain of the function. If it's not going to be in the domain of the function, you cannot consider it. That's why we determine the domain of the function. Okay, so this is how we're going to conclude for the rest of the problem. We did f prime equal to 0, we didn't get anything. But you are going to tell us that, note that f prime at -5, f prime of -5, because the denominator would be 0, whatever is 0, whatever value that makes the denominator 0. Note that f prime of -5 does not exist. And more important, and x equal to the -5 is in the domain of the function. You need these two conditions, both of them. Okay, so x equal to the -5 is going to be, is a critical number. So you are going to have only one critical number for this problem. The critical number is going to be -5. That's a point about the radical function. It's happened for the radical function because your domain is -infinity, positive infinity. But when you differentiate, you see down the denominator, you may get some extra. We call it free critical numbers. So make sure don't miss it, or that second part. Any question? So this is one type for the radical function. There is another one that we talk about it when we give you this lecture. And there is one over here. I'm going to check that one for you too. Okay, it's very similar, but you got more to talk about it. So this is going to be part C of this is number, what number was it? Is a number, okay, this is a problem 2. So that was a 2. Okay, this is problem 2. That was a 2A. And this is going to be 2C. Let's see what is special about 2C. You see, in 2C, your function is f of x equal to cube root of 9 minus x squared. I discussed this one for you, a similar one. Again, you have to start with the domain. Index 3 is odd, so the domain is all real numbers again. Okay, so the solution, always the domain. So we say that the index of the radical 3 is odd. Okay, index of the radical is odd, and so the function is going to be defined. Okay, and so, basically the domain of the function is going to be -infinity and positive infinity. So again, you have a nice domain here. Any question? You want to differentiate. Of course, you have to change it. So change the radical function. It's going to be f of x equal to, we change it, it's going to be 9 minus x squared to a third again. So again, is like u to the 1/3. You differentiate it using the chain rule. Okay, so it's going to be the chain rule type. So it's going to be f prime of x. Okay, the power down. So that give it a third. 9 minus x squared to the 1/3 minus 1 is like 1 minus 3, which is a -2. So that give me -2/3. But u prime. U prime derivative of the inside. This time the derivative would be -2x, like the one on your quiz. Okay, any question? So we have u to the 1/3 in this case again. We apply the chain rule. On the test, a couple of you just make it so complicated to take this derivative. I don't know how did you take those. I never did this type of very ancient method, if you like, that you're going to use. Of course, if you search on internet, those give you those very classic method. Okay, but don't make calculus so complicated. Okay, I was surprised that the way a couple of you did it. For example, you just use the notion of the ddx, and for this one somebody write 1/3 of the 9 minus x squared to -2/3 times the ddx of 9 minus x squared, And then you go inside and you write t dx of the 90. I don't know. How did you pick this type of methods? I never talk about it. Okay, so nice. That's it. You see, that's a chain rule. U to the 1/3. Bring it down. U to the negative 2/3. U prime. So U prime, you see derivative of a function like 9 minus x squared. You don't need any theorems, okay, to take care of this one. Derivative of a 9 is 0, derivative of x squared is negative 2x. Okay, you're done. So, because when the problem getting complicated, you spend so much time on those easy details that you may miss the main one. Okay, so we simplify it. It's going to be f prime of x equal to, you have to simplify it. Some of you didn't do it on the quiz. You have to put this one up in front. It's going to be what? It's going to be negative 2/3 of x, or 2x over negative 2/3 of x times a 9 minus x squared to the negative 2/3. Now we change it into the fractional form because we want to find the critical numbers. If it's going to be just a derivative, you don't have to. But since you want to continue, you get a fraction bar. On the top, we get the negative 2x, okay? And on the bottom, we get the 3 times 9 minus x squared to the positive 2/3. Okay, so this is going to be your f prime in this case. Okay, any question? So that is going to be 1. What is the question? Where is the 9 went? Derivative of a 9 is 0. Question? Yes.
So like when you did a prime of 9x squared to negative 2/3 times negative 2x, how come the 9 was gone if you multiply on the inside of u?
No, you see, derivative of 9 minus x squared. U prime. Derivative of 9 minus x squared. Derivative of 9 is 0. And derivative of x squared is 2x.
Oh, okay. Yeah. Thank you.
See?
Yeah.
Because we differentiate, it's going to be U prime.
Yeah. Okay. Thank you.
Okay, very good. Any more question? Yes.
How did you get -5 for the for letter A?
The previous one, you see -5, you just check the denominator. Check for what value of x denominator would be 0. You see, the number is 5 plus x, okay? If you let 5x, 5 plus x equal to 0, x would be -5. Remember the rational function? The rational function is going to be undefined when the denominator is 0. This denominator, you have 5 plus x equal to the 0, you see? This is 5 plus x equal to the 0. X would be -5. We're going to do it again over here in a minute. Okay, any question? Now, so that's your f prime. Now, I just want you to compare these two together to see what's going to be the difference. There is a big difference. You see now we let this one equal to the 0. If you let it equal to the 0, the top would be 0. But the top this time is a -2x. -2x equal to the 0, that gives x equal to the 0. You see? In the previous one, look at this one. The top was a constant. 1 equal to 0, never. You didn't get any solution. But over here is going to be 2x. So we get one solution. But you are not done. You have to do the same thing that we did for the other ones. Denominator. Check the denominator. See this denominator? For what value of x this denominator would be 0? Any suggestion? Denominator is 9 minus x squared. For what value of x this would be 0. Denominator would be 0 at, yes, Catalina, -3 and 3. Okay, yes, positive -3. You see, the denominator would be 0 at positive -3. Positive -3 are in the domain. So at this point, we have a sharp corner or vertical tangent line. So both of them are going to be critical numbers. Okay, so these are the ones that you should miss. So we say, oh, this is going to be the case. Again, you make a statement that this is it. Note that these are the one that some people miss it on the test. Note that x equal to the positive negative 3. Okay, these are going to be one. X equal to positive negative 3 is in the domain, and f prime of negative 3 and f prime of positive 3 do not exist. Okay, because the number that would be 0, the fraction is going to be undefined. So both of them are going to be your critical numbers. So I continue here to finish it. So x equal to the positive negative 3 are also critical numbers. Critical numbers. So the conclusion is going to be critical numbers are going to be 3 numbers. Negative 3, 0, and 3. This would happen only for this type of radical function. So you got to be careful. We call them free critical values because they are not coming from the from the part that you put f of x equal to the 0. They come in from the part that you let the denominator equal to the 0. Okay, and this happens for the radical function only. Any question? So we are interested in this type of the critical numbers for the radical function. These are the only possibilities for the critical numbers. Okay, the other one is going to be rational function that you have to use the quotient rule to find the derivative. And I told you polynomials, we are not going to use polynomials because the polynomials are going to be used in other problems that we're going to have. Okay, so let's check that rational function that we have. This is 2b. So we give you one radical, one rational, but this is going to be just one question. And we post a take on one for you so they can practice. Okay, it's going to be the quiz number, maybe number 4. Okay, I'll post that one to you too. So let's see what's going to be 2b. 2b is a rational function, f of x equal to, the top is x squared plus x, the bottom one is x minus 1. Okay, we give you something that you have to apply the quotient rule to differentiate it. Okay, domain first. You know that it's a rational function. It's going to be undefined for a value of x that met denominator equal to 0. Denominator is x minus 1. So denominator would be 0 at x equal to 1. Remember, when we identify the domain, this is a negative infinity, and this is a positive infinity, and you have the 1 here. So you have a hole, if you like. So the domain of this function is everything except negative, positive 1. So it's going to be negative 1 to 1, union with 1 and positive infinity. That's your domain. Any question? So domain is very crucial. So we have to find the domain first. Now you differentiate. You must be careful. When you want to differentiate, you have to use the quotient rule only, okay? Quotient rule, derivative of the top times bottom minus the bottom times top. Let's try. If of the top one, use power rules to differentiate it. Of x squared will be 2x. It's going to be 2x plus 1. You have to open up the parentheses. Times it by the bottom, which is x minus 1. Minus. Lift up the bottom one, lift up x minus 1, just 1. Times the top. I write it down so that you know that you have to put it inside the parentheses and multiply by the top. Divided by the bottom is squared, x minus 1 all squared. Question? You continue on the top. You have work to do because you have to FOIL it. You have to FOIL this one, distribute everything nicely. Okay, simplify. So it's going to be equal to, FOIL the top, multiply, go forward, 2x times x, 2x squared, plus 2x, minus, positive, negative, minus, positive, negative, negative. 2x times 1 would be negative 2x. You go inside plus x, and positive negative would be negative. Then we have a -1 over here, so it's going to be negative x squared minus x. Okay, and the denominator is x minus 1 all squared. Okay, continue, simplify it. Combine the like terms. So the top we have 2x squared and x squared. Let's make it into just 1x squared. Okay, and these x positive and negative would be cancelled out. So these two would cancel. So what we have a negative 2x, negative 2x minus 1, divided by x minus 1 all squared. It's not going to be a nice one, but this is a problem in your book, one of your assignments. So I just want to show you what would happen for these type of problems. Okay, any question? You let it equal to 0. So the top must be 0. The top is x squared minus 2x minus 1 equal to 0. The one that we are going to give you is nicely factorable, and this one is not. You cannot factor it, so you have to use quadratic formula. Okay, you know, this is from your book, so in case you arrive at this type of problems, so the only possibility is going to be quadratic formula. So I use quadratic formula. A is equal to 1, B is equal to the -2, and C is equal to the -1. I check to see if I have any solution. So I use discriminant delta B squared or D minus 4AC. So that gives me -2 squared minus 4 times A times C, 1 times -1. So -2 squared would be a positive 4. And over here, negative would be positive. So that gives me 8. It's not a perfect square, but it's positive. So I can use quadratic formula to get the results. Say x equal to the quadratic formula, negative b plus or minus radical delta over 2a. You just substitute, it's going to be equal to negative b is going to be -2 because the b is -2, plus or minus a radical 8 divided by 2 times a, 2 times 1. So this is going to be 2 positive negative radical 8 divided by 2. We don't want you to use calculator to give us a decimal number, but radical 8 would be, you see radical 8 would be 2 times 4, so that gives you 2 radical 2 if you want to simplify it. So it's going to be 2 plus or minus 2 radical 2 divided by 2. Now you can simplify these two coefficients. So the result would be 1 plus or minus radical 2. So x would be 1 plus or minus radical 2. These are going to be your critical numbers. Again, the one that you are going to have is nicely factorable, but in case you want to solve the problem in your book, this is one of them. Okay, I give another one so that you can see when it's going to be easier to handle. How are we going to take care of it? Okay, so for the rational function, basically, this is the quotient rule that we have to use to get this done. And you find that you cannot talk about the one that you have for the radicals. You see, some people, they say, oh, denominator would be 0 at x equal to 1. So as we did for the radicals, x equal to 1 must be a critical value. But the difficulty is, you see, x equal to 1 is not in the domain of your function. You see, so you cannot consider it. So that those methods that I talk about is no good for the rational function. It's good for the radical function because you see the domain of the radical function are all real numbers. So that's why you have that second option to take care of this. Okay, I'll give you one more of this fractional one. Let's call it 2D so that you have something which can be factor, the type that you will see on the test. Check this one. This is again a very popular group. Let's have x on the top, but x squared plus 9 at the bottom. So you don't have a D on the practice one. So I just call it D. So give you one extra problem. And this is in fact interesting. What's the domain of this function? Any suggestion for this one?
All real numbers.
Or real number, very good. You know that denominator cannot be factored. X squared plus 9 is not factorable, so it's never zero. Okay, so the solution is going to be, you mentioned that x squared plus 9 is not factorable. You can factor x squared minus 9, remember, not x squared plus 9. So x squared plus 9 is not factorable. Okay, factorable, and the domain is all real numbers. Nice. That's the domain. Differentiate. Quotient rule again. Carefully apply the quotient rule. Derivative of the top times bottom, bottom top. Derivative of the top, derivative of x is 1. 1 times bottom, x squared plus 9 minus derivative of the bottom times top. Derivative of the bottom on derivative of x squared is just 2x. 2x, derivative of 9 is 0. 2x times top, which is x, divided by the bottom square. Okay, so I just apply the quotient rule. Derivative of the top times bottom, bottom top. You continue on the top. You see, simplified, you multiply first, and then simplify. So it's going to be equal to, so it's going to be simply just x squared plus 9 minus 2x times x would be 2x squared. Okay, divided by x squared plus 9 all squared. Combine the like terms. You have 1x squared minus 2x squared, that gives me negative x squared. Okay, so it's going to be equal to the negative x squared plus 9 divided by x squared plus 9 all squared. Any question? So I just combine the like terms. I have 1x squared minus 2x squared. Now we let it equal to the 0. Again, top would be 0. Top easy to factor. Negative x squared plus 9 equal to the 0. You can solve this equation. You can factor it, or you can move one of them to the other side. I move the x squared to the other side. And then I take the square root. So x would be positive negative 3. That's it. So the critical numbers are going to be negative 3 and positive 3, and do that. Okay, so that's going to be this type of, the type that when you want to work on the top, it's nicely factorable, okay, and it can be done. Okay, so this is going to be our first topic. Okay, the new one that we did have. So one question, finding the critical numbers, but the functions, special functions. There are 2 more functions that you're going to see at the end of the course for the critical numbers. But for the time being, this is all we are going to have. Yes, a fraction is 0 if only the top is 0. Okay, that's going to be, that's the way we have to get these numbers. Okay, so this is going to be the bond. Okay, somebody asked for the, okay, this was the first one that we did. Okay, x squared plus x, or x minus 1, we did this one, and then this is the second one that we did here. Okay, so that's the first topic, one question. Okay, one new question. Any question? Now, what is going to be the next one? The next one, of course, application of the critical numbers. 2 cases. Case 1, finding absolute max, absolute min. Case 2, relative max, relative min, which is the first derivative test. One question from each, okay? Let's do it. Absolute max, absolute min is easier to handle. So we give you one from this and one from the other one. Okay, doesn't matter. All of them are going to be the same thing. Okay, so I go to number 4, according to the topics that we studied. So number 4, finding absolute maximum, absolute minimum. Okay, absolute max and absolute, okay, absolute minimum. This is very straightforward problem. We talk about it. We can do it only on closed interval for the time being. Okay, this is going to be on, just emphasized, closed intervals. So the procedure was, remember, we have a theorem, a Cauchy theorem, that will tell us that this is always possible. So we don't have anything to worry about. How we're going to find it? What's going to be the candidate? A function would be given, it's going to be a polynomial. You differentiate it. You let it equal to the 0, you find the critical numbers. If the critical numbers are going to be in your domain, you are going to select it, find the value of the function at the critical numbers, and at the end point of the intervals. Interval is close. So you have the right end and the left end. So we get a bunch of numbers. The smallest one is absolute minimum, largest one is absolute maximum. No test, nothing is needed for this one, okay? So it's straightforward, just make sure that when you differentiate it nicely, okay? So there you are. This is number 4. And mostly we give you either a cubic polynomial or a 4th-degree polynomial, and you have all of them over here. So I do one cubic one and one raising to the 4 to just make sure you are able to solve the resulted equation, okay? So let's do the 4a first. The 4a, the function is, this is it, f of x is equal to negative x cubed. Okay, negative x cubed plus 3x minus 5. We want to do it on this interval, closed interval of a -2 and 2. That's it. Absolute max, absolute min. Step 1, you see critical numbers. You remind yourself that the domain that you have to consider is not the natural domain of the function, this domain. Okay, because the natural domain is all real numbers. This is your domain for this problem. Okay, because they ask you to restrict it on this domain only. Now differentiate carefully. Power rule. It's a -3x squared plus 3. Derivative of 5, 0. Okay, that's your derivative. Let it equal to 0 to find critical numbers. So f prime of, okay, f prime of x equal to the 0. F prime of x equal to the 0. That will give us a -3x squared plus 3 equal to the 0. But you have to solve this equation. You can factor out the -3 if you like, do it, or just move one of them to the other side. You know, it depends what you want to do. So this is it. I move one of them to the other side. I write it down as a 3x squared equal to 3. Okay, I move this one to the other side. Then I divide by 3, so x squared equal to the 1. So x would be positive -1. That's it. So we have 2 critical numbers. Critical numbers are going to be -1 and 1. Any question? So make sure to solve this equation, okay, correctly. Now we check to see if you are going to accept those 2 numbers, okay? Checking, check. So you check with your domain. You see the domain is between -2 and 2. So -1 is in the domain and +1 is in the domain. So we check and we decided that both numbers are nice. So we are going to use both of them. Okay.
Professor,
Yes.
sorry to interrupt. But when you move the 3 to the other side, wouldn't it make it -3?
No, I moved -3x squared to the other side.
Oh, okay, thank you.
It's the same. If you want to move the other one, is going to be, you see, if you want to move your -3, so that give you this one. Okay,
Mhm.
so now negative would be positive. So x squared would be 1 again.
Okay,
Okay,
thank
so
you.
it doesn't matter, you know, you can move 1.
Okay,
Okay, no problem. So this is going to be the case. That is going to be 1. Okay, so, you know, it's like looking into the mirror. So I did the other part. So that's, we checked it. We checked it. We decided that we are going to use it. Now, remember, you have to find the value of the function at -1, +1, endpoint of the interval, -2 and 2. That give you a bunch of numbers. The smallest one is the absolute minimum. Largest one, absolute maximum. So we have to check first. Now we get a kind of a table and we do this calculation all together. So this is the x, and this is going to be your f of x, the function. F of x is what? Is a -x³ plus 3x minus 5. Now the numbers that you have to use are critical numbers, -1, +1, and the point of the interval. The interval is a -2 and 2. That's it. You find these numbers and you compare them together. No table, no nothing, okay? Substitute, use parentheses carefully, -1³ plus 3 times a -1 minus 5. -1 to the third would be negative, but there is a negative sign outside, make it into the positive 1. Over here, positive negative would be negative, -3 minus 5. So -3 minus 5 would be -8. 1 minus -8 would be -7. This is the first number that you get. Any question? So make sure to do the algebra, you know, correctly. We put the 1, that's easy. When you put the 1, it's going to be just a -1 plus 3 minus 5. So -1 and -5 would be -6. So it's going to be 3 minus 6, which is going to be -3. This is the second number. Any question? Check -2. Substitute -2 to the third plus 3 times a -2 minus 5. -2 to the 8, -2 to the third would be -8. But there is a negative outside, making it to the +8. Okay, 2 times 2 times 2 would be 8. And over here, positive negative would be negative. It's going to be -6 minus 5. So it's going to be 8 minus 11, which is going to be -3 again. Okay, I just double check this. It's a -1, -1, 3, and 5. Yes, that's the case. And we put the -2 here. -2³ would be -8, negative, positive. Okay, and that give us the same thing. Okay, now we've checked the 2. It's going to be -2³. Okay, plus 3 times 2 minus 5. So 2³ would be 8, but there is a negative outside, make it to the -8. Positive would be positive, we get a +6 minus 5. So it would be what? It's going to be -13 plus 6, which is -7 again. Okay, that's it. Any question?
Yes, I have a question. For
Yes.
the top where you wrote down like checking the critical numbers, whether
Yes.
we're inside the domain. For the test, in regards to the test, do we actually have to like write it down, or would you automatically assume that like we know whether they are in the domain or not?
Yeah, you just have a look.
Oh, okay, yeah. Yeah, I was just wondering if you actually
No.
have to write it down. Okay.
No.
thank you.
You just have a look in case you want to, you know, that if it's not, you drop it here. You see, cross it.
Oh, okay, yeah, thank you.
No, I write it down. Just make sure that this is where you know, you talk to yourself there. Check. Okay, check before going to the next part. Because remember the other night I gave you examples that these points were not in the, you know, in the interval. You know, just check what you're saying, you know, check out. That's it. We accept that. Okay, now we have these numbers, you compare them together. The largest one is the minimum value, the maximum value, the smallest one is going to be minimum. Okay, you have to write it down. What's the minimum? Between these numbers, which is the smallest one? You have -7, -3. Minimum, -7. That's a minimum. And the maximum value is going to be -3, and you're done. Okay, it's a straightforward problem, but your difficulty is sometimes, when you calculate it, just make sure the numbers, and important part is don't bring anything extra. In this case, everything very nice. You get these numbers.
For the
Yes,
X, we usually can use those 4 numbers.
this is the only thing you do. Yes.
Okay. We just
Yeah,
plug in
Yeah,
negative.
because they are the candidates. They know the maximum and the minimum. They are going to be one of these. Remember, because of the theorem that we did have. That's why you are not going to go anywhere else. You're just checking these numbers. Okay, any question? So this equation was a cubic one. And sometimes the equation may be something, of the 4th degree. So check one more for you of the 4th degree to see how we're going to handle those type of problems. These are going to be the only possibility that we have. Okay. What's the question? What do you mean equal different numbers? If they are going to be, what do you mean? If they are equal numbers, just pick one of them. You see, you have you have 2, -3. It doesn't matter. You see the minimum value and the maximum value. You see, you may get minimum at different places. You see, you get the minimum. Remember, they are minimum and the maximum value. Sometimes some people talk about the minimum point. You see, you have 2 minimum points, -1 and -7, and you have a 2 and -7. They are minimum points. But the minimum value is -7. It's like minimum wage. Okay. When you talk about the minimum wage, there are many people who get the minimum wage, but we call it the minimum, which is going to be -7. Okay, so this is going to be the case. Let's check one with the 4th degree to see one for the 4th degree. You may get more numbers. Look at these numbers. Okay, and this is straightforward one on this test. Everything we do on this test with these new parts would be repeated on the final. I told you the other night. Okay, so keep these and you have it for the final exam too. Okay, let's check. I think one of these would be unusual. Let's check C for the 4th degree. If we get time, we can go over the T2. But 2 possibilities with the 4th degree. So that's going to be f of x. You have the f of x and it's a -3x to the 4th. Okay, plus 8x cubed. 8x cubed minus 10. And the interval in question is a -1 and 1. Okay, we want to check the max and the mean over here. Okay, so the solution, we make sure that we know that the domain in this case is going to be -1 and 1, and this is where you have to check your critical numbers. Okay, differentiate carefully. F prime of x is going to be equal to the power rule, 4 times 3, 12, so that gives me -12x to the 3rd. Okay, and that would be plus 24x. This is f prime. Okay, let it equal to the 0 to see what is going to be your possible solutions. So we have a -12x cubed plus 24x equal to the 0. We have to solve for factoring. What's a common factor here?
Wouldn't the f prime of x be -12x cubed plus 24x squared?
Oh, yes. Thank you. Very good. Yes, thank you. Excellent. That's it. Yes. Okay, so what's going to be common factor now?
Could it be negative 12 or 12?
And
Negative 12x squared.
yeah, negative 12x squared, negative 12 or positive 12. It doesn't matter, but you have to pick the x squared, okay? So we need to have the x squared, okay? So we may go with the negative 12x squared. So the leftover here is going to be x, because this is x cubed. And this would be minus 24 divided by negative 12. It's going to be minus 2 equal to the 0. Okay? And so we have two factors. It is a repeated factor. We call it 12x squared equal to the 0. So you drop the 12, so that gives x squared equal to the 0. If you take the square root, x would be 0. This is one of the solution. Any question? Some people, they say, oh, I cross out the negative 12x squared. You can't do it. You can cross out negative 12 because it's a number. Cross out means I divide. You can divide by negative 12 because it's a number, but you cannot divide by x because you will lose the solution. Okay, and the other factor is x minus 2 equal to the 0. So that gives us x equal to, okay, x equal to 2. That's it. So we have two critical numbers. We have two critical numbers, going to be 0 and 2. Okay, any question? You check what's happening in here. You see, if you check, remember the domain that you have in negative 1 and 1. Negative 1 and 1, 0 is inside of a negative 1 and 1. But 2 is not. You see, 2 is outside. So you cross out the 2. You cross out the 2. So the only one that you are going to accept is going to be 0. Okay, that's why, you know, we've emphasized that you have to check it. You may cross both of them out. It doesn't matter. You go to the next step because you always have the endpoint of the interval.
So you cross out the highest value between the two?
No. You cross out whatever it's not inside. You see what is your domain now? Your domain is negative 1 and 1. Okay.
Oh.
So 2 is not between negative 2. You see, this is it. So everything in this interval, you are going to accept it. 2 is here, out. Okay. So that's why we say check. Check to make sure you know. Okay, any question? So this is going to be the case. We have only one critical number. So the rest is going to be, you are going to evaluate the function. Okay, you evaluate the function at 0 and at negative 1 and 1. You have three numbers to check. Okay, so this is it. You have one column over here for, this is going to be your x, and this is going to be your f of x. And your f of x is negative 3x to the 4th. Okay, plus 8x cubed, and the minus 10. So from the critical values, you get only one number, which is 0. And from the end point of the interval, you have a negative 1 and 1. So if you bring the 2, it's wrong. Because you bring the 2, you compare these numbers, you may pick the maximum, the minimum at 2, but 2 is not in the domain of the function, you see? That's why you have to be careful about that part. Okay, if you put the zeros, these are going to be 0, you get only negative 10. Okay, if you put the 0, it's going to be 0 minus 10, so that gives a negative 10, one number. If you put the negative 1, you have to use parentheses carefully, negative 3, negative 1 to the 4th, plus 8, and negative 1 to the 3rd, minus 10. Negative 1 to the 4th would be a positive number, a positive 1, so that gives a negative 3. But negative 1 to the 3rd would be negative 1. So negative 1 times positive 8 would be negative 8 and minus 10. So that gives you negative 20, 21. Any question? A 1. If you put the 1, that gives you negative 3 plus 8 minus 10. So that gives you something like a negative 13 plus 8. And the result would be a negative 5. There you are. So you have three numbers to compare. negative 10, negative 21, negative 5. Okay. What is the minimum? Minimum, smallest value between negative 10, negative 21, and yes, you are all right. Negative 21 is going to be the minimum value, okay, and the maximum value. Okay, with this number, we have a negative 5, negative 21, negative 10, and the maximum would be, okay, yes, negative 5, you're all right. So negative 5 would be our maximum at beta. Okay, so just be careful. Don't bring anything extra. That's the message. Otherwise, it's going to be a straightforward problem. If you get time, I come back. I do one more of those, the fourth degree. But just try it and keep the solution, as I told you, for even for the final, okay, for the final exam. So that is topic number 2. We give you one polynomial. We give one polynomial and we ask you to check for the absolute max, absolute minimum. Okay, are you ready for the next one? The next one is going to be increasing, decreasing function and finding the relative maximum or minimum. So this is where we are going to use the first derivative test. It takes a little bit more time, but it's not bad. Okay, so this would be the next topic that we have. It's first derivative test, first derivative test. Okay, first derivative test and finding relative extrema. Means a maximum or a minimum. This is where you have to, okay, you have to give us a chart for the f prime, identify where the function will be increasing, decreasing, and the, okay, and the rest of the story, if you like. We may give you 2 of these or just one. So let's try. So this is going to be all question number 3. Okay, so we start with the 3a. What is going to be the 3a? 3a, the function is f of x equal to f of x equal to the x cubed. Okay, x cubed minus 6x squared plus 9x plus 1. Okay, this is the function, and you want to check, you know, for the relative max and the minimum. Okay, step 1, you know that the candidates are going to be critical numbers again. So we have to find the critical numbers. So in order to do it, we need the domain. So always we start with the domain of the function. So the solution is going to be, you know that this is a polynomial, so the domain is all real numbers. So that's your domain. Then as usual, you have to find the derivative of the function, the derivative equal to 0. So we go with the f prime of x equal to, okay, exponent times coefficient, the power rules that give you 3x squared. And this would be minus 12x plus 9. This is the derivative, double check. Make sure that everything is all right for the derivative of the function. Okay, we highlighted because we are going to use it. You let it equal to the 0, f prime of x equal to the 0. So we have to solve this equation, 3x squared minus 12x plus 9 equal to the 0. Try factoring first. You can factor out the 3 out first, okay? Take out the 3, so that gives x squared. And this would be minus 4x plus 3 equal to the 0. Okay, make sure you get the factoring all right. Then we go on, we want to find 2 numbers with the product of 3. This is positive, so product of 3 and the sum of 4. Okay, the number is going to be easy to find. It's going to be 3 and negative 3 and the negative 1. Okay, negative 3 times negative 1 would be a positive 3, and negative 3 minus 1 would be negative 4. Okay, so factors equal to the 0, 3 equal to the 0, never. It's impossible. Okay, but x minus 3 equal to the 0, x minus 3 equal to the 0. That give you x equal to 3, one solution. and x minus 1 equal to the 0. That gives you x equal to 1. So we are going to have two critical numbers. So the critical numbers are going to be what? Are going to be 1 and 3. That is your critical number. You don't have to check because it's automatically in the domain of your function. Okay, that's going to be the step 1. Step 2 for this problem, you have to drop them back into the function because you are going to talk about the maximum and the minimum value. Okay, so these are going to be candidates. So we have to check it. So drop it back into the function. That's going to be a step. Okay, that's going to be a step 2. Step 2, what's going to be f of 1? In the function, you see this is going to be your function. You substitute x equal to 1. So that give 1 minus 6 plus 9. Okay, plus 1. So it's going to be 1 minus 6 plus 9 plus 1, which is equal to, okay, we simplify it. The positive 1 to 10, 11, 11 minus 6, which is equal to 5. So you highlight it because this is one of your candidates for the maximum or a minimum. Okay, f of 1 equal to 5. Then you try again for x equal to 3. So we find f of 3. Go to the function again, substitute. Okay, to get these values. So if you go back and substitute, that gives us a 3 cubed. Okay, minus 6 times 3 squared plus 9 times 3 plus 1. Okay. Again, carefully evaluated. 3 cubed would be 27. 3 squared would be 9, and 9 times 6 would be 54. Okay, that's going to be 1, and 3 times 9 would be 27, and plus 1. Okay, simplify 27 and 27 would be 54, and the 54 would cancel out. So these are going to be 0. So the leftover is going to be just 1. Okay, so f of 3 is equal to 1. So these two are going to be your candidates for the maximum or the minimum, but you have to test it. Okay, so we test it, test. The test that we're going to use is first derivative test. In future, after your test, we are going to have another one as well. We call it the second derivative test. But for the time being, you do have only this test. So for this test, remember, we need a chart. You have to draw the chart. In this chart, the first part is x, number line from negative infinity to positive infinity. The second part is f prime, the derivative. Okay, that's the second part. And the third part is just the function. Now we're testing the critical values. We have two numbers, 1 and 3. 1, 3. How we get it? We let f prime equal to the 0. So f prime is 0 is here and here. So that would partition the number line. You see 1, 2, 3. F of x, f of 1 is equal to 5. And f of 3 is equal to 1. You have to check the sign here because if the f prime is positive, remember, the function is going up, up. If it's a negative, it's going down, down. And we talk about a different method. We are going to do it in case you bring your f prime to see what type of function is f prime. F prime is quadratic. You see 3x squared minus 12x plus 9. We talk about it. If it's quadratic, between the solution, the sign of the f prime is the opposite sign of the x squared. Sign of the x squared is positive, so f prime is negative. Everyone else is the same sign. Positive, positive. That's it. okay? If you don't like it, you're just checking some test numbers. But for the quadratic, this is the way you are going to know to operate. You don't need anything else. Two solutions. Between the solution, opposite sign of the x squared. Sign of the x squared is 3 is positive, the opposite would be negative. Everywhere else, the same thing. Now, in the direction, f prime is positive, so the function is increasing. F prime is negative, the function is decreasing. And f prime is positive, the function is increasing. That's it. So this function would be increasing on the interval of negative infinity and 1, and 3, and positive infinity. Up, down, that gives us a maximum. Down, up, that give you a minimum. That's it. So f of 1 equal to the 5, f of 1 equal to the 5 is a relative maximum. F of 3 equal to the 1 is a relative minimum. If you give us this chart, you don't have to explain anything because it's all self-explained. If it's not going to be chart, you need a chart, okay, because that's a theorem. That's a theorem because this depends on the sign of the f prime. Remember, we talked about it. If the f prime is positive, the function is increasing. And if f prime is negative, the function is decreasing. So that's why we call it first derivative test. So you have to have this chart so that you'll be able to to refer to that theorem and get your conclusion. Otherwise, you will lose point if it's going to be on the test. And some people they say, oh, this is it. F of 3 is 1. I compare 1 and the 5. So this is a minimum, that's a maximum. No, it's not the case all the time. Sometimes you may find a function. I think we have one. Maybe I can explain that one later, that you will get the situation that is going to be the case. Yes, we have one, part D. Okay, I checked that part for you so you will see that this is not going to be always the case. Okay, that you may get something that's going to be out of your reach if you like. So we have to check it to make sure that everything is going to be all right. Okay, I give a break now. We come back. I give one more for this one, and then we continue. We have one more new topics to check, and that would be rate of change. Then we can go over that problem of the chain rule. I have a couple of them over here, or implicit differentiation, to make sure that you remember those numbers. I just put the application problem I saw on the quiz that you did very well on those rate of change for the revenue function. So we may check the profit function so that you know that we may give it a profit. Okay, at 10 minutes, it's 8:23. Then we come back and we finish it. Okay, see you then. Okay, so that's first derivative test. Okay, I'll give you another one so that you can see that sometimes you may see something different, okay? Because just show you that you have to use this test, okay, to get the numbers involved. I just check this question that you have. So I give you one myself so that you get the situation that you may be surprised. Okay, so I'm going to call it, just add it to this collection because I won't see anything. I'm going to call it 3D. Okay, 3D. And the 3D, sorry, let's have this function. You see f of x equal to, it's x to the fourth minus 2x cubed. Let's see what is special about this one. Okay, there is one type of examples that you should see one. Okay, so the domain is again a negative infinity, positive infinity. That's your domain. You differentiate it. F prime is 4x cubed minus 6x squared. You see, this is going to be the case. So you let f prime equal to the 0. F prime equal to the 0. So you have to solve this equation. It's a 4x cubed minus 6x squared equal to the 0. You know that you have to use factoring. What's a common factor here? Common factor,
2x
2x
squared.
squared. Yes, 2x squared. 2x squared out, so the leftover is going to be what? Is going to be 2x minus, okay, 2x minus 3 equal to the 0. We need the factor to be equal to 0. You have 2x squared equal to the 0. You know that you divide by 2, that give you x squared equal to the 0, because x squared equal to the 0 over 2, if you like. It's 0, and you take the square root, that give you x equal to the 0. Okay, so that give you x equal to the 0, which is going to be one of your point. And then you let 2x minus 3 equal to the 0. So that give you x equal to what? X equal to the 3/2. So you have two critical numbers. So the critical numbers are going to be 0 and 3/2. Question? No checking is needed because its domain is negative infinity, positive infinity. So these are the candidates. Drop them back into the function, then get a chart. So we check f of 0. F of 0 gives us 0. So that would be one candidate for the max and the mean. Okay, then you have to find f of 3/2. It's 1.5. You can use your calculator or just substitute. So if you substitute that, give it 3/2 to the 4. Okay, minus 2 times 3/2 to the 3rd. Okay, if you feel uncomfortable, you can call it 1.5 and just use calculator, to get these numbers. But if you want to stay with the fraction, it's going to be equal to the 3 to the 4th would be 81. 2 to the 4th would be 16. And this would be minus 2 times 3 to the 3rd would be 27. And 2 to the 3rd would be 8. Okay, then a 2 and 8 would be simplified. So that gives 81 over 16 minus, minus 27 over 4. Okay, I simplify this. We have to find the common denominator. And the common denominator would be 16. So that gives 81 over 16. And this would be 16. You have to multiply the top by 4. 4 times 7 would be 28. 108. Okay, and you subtract that, the result would be negative is a 16 and 81 out of 108, which is going to be, okay, that's it. That give you 27. Okay, so that is going to be f of 3/2 equal to negative 27 over 16. Any question? Let's see what is special about this one. It's the one that I talk about. Somebody say I don't need a chart because f of 0 is 0. So f of 3/2 is negative 27 over 16. So this seems to be minimum. This seems to be maximum. But let's test it. Test first derivative test. So for the first derivative test, remember you need a chart. This is going to be the chart. X from negative infinity to positive infinity. F prime of X. That's your F prime. And this is going to be your F of X. Now, critical numbers are only two critical numbers. You have 0 and you have the 3/2. So F prime is 0 at these two places. F of 0 is equal to the 0, and F of 3/2 is a negative number. So you have to check the sign here. You have to look at your F prime. What is going to be your F prime? You see this F prime is equal to what? F prime is a cubic function. It's not quadratic. You see, this is your F prime. So you have to test the numbers to find out what will happen to the F prime. But you see from 0 to the negative 27 over 16, this is a decrease because you get a negative number. So you have to check two numbers here. You see one here and one here. The previous one I didn't check because that was quadratic, but this is cubic. When it's a cubic, you have to test the numbers, okay? So pick one number, give us a number between negative infinity and 0. Pick easy number.
1.
Between negative infinity and 0.
-1.
Sorry.
Negative
Negative
1,
1.
okay? Negative 1. So check the negative 1. What is f prime of negative 1? That gives you 4 times negative 1 cubed minus 6 times negative 1 squared. Negative 1 cubed would be negative times 4 would be negative 4. Negative 1 squared would be positive times negative 6 would be negative 6. So that gives you negative 10, which is negative. Okay, so this is negative. This is already negative. So look at this one. Negative, negative. So in this direction, you see that was a critical point, but you don't see any changes. So this means this f of 0 equal to 0 is not a maximum and is not a minimum, but it's a critical point. If you don't test it, you won't see it. Okay, that's why I'm just telling you that you have to test these numbers, okay? And you pick a number here. This is 1.5, you may pick 2. So if you find f prime of 2, so f prime of 2 would be 4 times 2 cubed minus 6 times 2 squared. 2 cubed would be 8, 8 times 4 would be 32. 2 squared would be 4, 4 times 6 would be 24. That's 8 is a positive number. So this is positive. Positive means up. So this function would have only a minimum, no maximum in this case. Okay, because this is the nature of this function that you get the decrease. See around the 0, the function stays the same, it's decreasing. So since it's decreasing, this 0 cannot be a maximum or cannot be a minimum. They call it a stationary point. You know, in some calculus book, not in your book. They call it a stationary point. A stationary point means it's a critical number, but it's not a maximum or a minimum. And it's happened for the cubic function. And the way we can identify is because of this x squared. Okay, you see this x squared? X squared is always positive. So that's why around the zero, you won't have any changes in signs. So be careful. This type of, you have to give us a chart. And this is the way I do it. You know, sometimes people, they don't give me a chart. They say, oh, it's always true. I say, okay, it's always true. There you are. I give you one function. One function that your case is not going to be true. So you have to test. You have to test. Okay, so we may give you two of these, or you may give you one. But it's not the case that all the fourth degree would have difficulty. No, the one that you have over here, it would be, you know, it would be fine. Yeah, you know, you get this. I can check it quickly so that you know that this is going, because we are going to use this type of function again. Any question? So you need the first derivative test to identify whether you get a maximum or a minimum. You have one with the fourth degree, but that seems to be a nice one. That's a 3. Okay, that's it. But that's going to be 3D again. So I have to call this one. Let's call this one 3E, because this is the extra that I gave you. So I check the 3D on your book, on your list. So you have to make sure that you have no difficulty applying this 4 degrees. Very similar, but the situation is quite different. Okay, let's take that 3D too. So the one that I gave you was not on your list, but you have to know it. So this is your 3D. This is nice. It, you know, it would give you, in fact, 3 points. So check this one. Again, the same thing. You can, you want to find the relative max or the relative mean. So we go with the domain first. Domain is all real numbers. So the solution is going to be, so the domain is negative infinity to positive infinity, nothing to worry about. Differentiate, carefully differentiate it. So that will give us 8x cubed minus 8x this time, which is nice. Okay, you let it equal to the 0. You have to use factoring. What's common factor this time? Common factor?
Is it 8x?
8x, yes, it's going to be 8x. So that gives us x squared minus 1. You see, this is nice. Because x squared minus 1 would be what? Would be x minus 1 times x plus 1. You see, 1, 2, 3. So 8x equal to the 0. You get x equal to the 0. One solution. Okay, x minus 1 equal to the 0. You get x equal to 1. X plus 1 equal to the 0. That gives you x equal to the negative 1. So we have 3 solutions, okay? So the critical numbers are going to be negative 1, 0, and 1. You don't have to check because the domain is all real numbers. Okay, drop them back into the function and then test it to see which one is going to be a maximum or a minimum. Okay, we tested into the original function. So we find f of negative 1. This is your function. You substitute here 2x to the 4th minus 4x squared plus 3. So f of negative 1 would be 2 times negative 1 to the 4th minus 4 times negative 1 squared plus 3. Negative 1 to the 4th would be positive 1, so that give only 2. That would be a positive one that give a -4 plus 3. So it would be 5 minus 4, which is a 1. That's the first number. So f of -1 is equal to 1. This is one candidate. F of 0, that's easy. That give you 3. That's the second one. Then f of 1. F of 1 would be 2 minus 4. 2 minus 4 plus 3. So that would be 5 minus 4. Again, you get 1. So f of 1 is also equal to 1. Okay, it doesn't matter f of -1 and +1 is 1. So get the chart. This is x from -infinity to +infinity. This is going to be f prime of x, f of x. You bring the critical numbers. We have 3 numbers: -1, 0, +1. Where did you get it? Get it by letting f prime equal to 0. 0, 0, 0. So you have 1, 2, 3, 4 region to check. F of x would be helpful. Okay, -1, f of -1 is 1. F of 0 is 3. F of 1 is 1. So you can compare these numbers, okay, to get the direction as much as you can. From 1, you go to the 3, that's increase. So that's a positive. From 3, you go to 1, this is decrease. That's a negative. So you have to check only 2 numbers. Okay, that would be helpful to get this short form if you like. Bring the f prime and check the couple of numbers. F prime is 8x cubed minus 8x. That's the original f prime. So we need 2 numbers. Okay, we check something like a -2 here. And we check something like a +2 here. To determine what's going to be the sign of those two regions. Okay, if you check the -2, so it's going to be f prime of -2, substitute. You'll see what's going to be the sign of that region. It's going to be 8 times a -2 cubed minus 8 times a -2. -2 cubed would be -8. -8 times 8 would be -64. And this would be a positive, okay, what's that? Positive 16. So this is not going to be negative because it's a -48. Okay, it's a negative, so this means this is going to be negative. So the function is going down here. Down, up, they give you the minimum. Any question? So we have to check +2 here. Okay, so what's going to be f prime of 2? F prime of 2 would be 8 times 2 cubed again, minus 8 times 2. So that gives you 64 minus 16. That gives you 48 positive this time. So this is positive. Positive means up. Nice. Down, up, minimum. Up, down, maximum. Minimum. You see, it was just a function of the 4th degree, but you have such a nice f of -1 equal to 1 is a minimum. F of 1 equal to 1 again is a minimum value, relative minimum, of course. And f of 0 equal to 3, that gives you a relative maximum. It's a complete course, if you like, for this type of problems. Okay, so the algebra involved, you got to be careful, double check, your derivative, double check your factoring. Just make sure to know you don't make any mistakes. Otherwise, it can be done. Okay, so that's the first derivative test. Okay, so we got the first derivative test, we get the critical number, and we get the absolute max, absolute mean on the closed interval. That is going to be what? Yes, you can check any number you like between, this is it, between negative infinity and -1, any number would be fine. As we pick something easy, okay? So -2 is easy number. You can check anything you like, -10,000. But pick something which is going to be easy to substitute, okay? To make sure to get it quickly. But any number would be fine. But you have to test. You have no other, no other choice for this. If it's going to be quadratic, it's straightforward. It's 2, you see, 3 region. But for the fourth, we have to check, especially to avoid, that method that we did have. Okay, so the last problem of this new part is rate of change. Okay, remember, we talk about all these functions that we have can be a function of time. So when we talk about the derivative is the rate respect to the x. But if it's going to be problem of rate of change, the variables are function of the time, then we have to find the derivative respect to the t. So let me remind you that one. Number 9 is related rate problems. Quite interesting problem. Okay, so it's going to be number 9. Related rate problems. Related rate problems, or that's it, problem. In this function, this format, we have the, you see, we have the x and the y. They are going to be related by one equation, but x and the y is going to be a function of t. So we use this formula if you want to find the rate of the y respect to the t, which is like velocity or the speed. Is going to be ordinary differentiation, which is the rate of y respect to the x, but you have to multiply by the rate of the x, dx dt. You see, you have x prime in this case and the y prime. They are a function of the function of t. It's the one that we discussed the other night. So the perfect situation is that we give you the cost function and the revenue function. So you can find the profit, then we ask for the rate of the cost, rate of the revenue, and the rate of the profit, okay? So a standard problem, but you got to be careful. So in this problem, this is it. We have the cost function. You see the cost function is 5,000 plus 2x. We have the revenue function, which is a 10x minus, 10x minus 0.001 x squared. So this is component 1. So the x is going to be the number of the production, okay? In this case, in this problem, you're producing flash drives, okay? So x is going to be a number of the flash drives that we're going to have. So they, remember we have something like, we call it related rates. We call it given rates. In this problem, they say where the production output in 1 week is going to be X flash drives. Now, if the production is increasing at the rate of 6,000 flash drives per week, you see, this is going to be your given rate for these problems. They give you the rate of the production. Rate of the production is going to be dx dt. X is a number of the product, okay? Rate of the X, the speed of the production, if you like. That would be dx dt. They give you this number. This number is going to be 6,000 flash drives. Okay, flash drives per week. Okay, so it's going to be 6,000 of unit per, you see that's going to be 1 unit per week. That's going to be your known problem. Unknown one is these cases that we're going to have, okay? The unknown one In the case of the cost, it's going to be, so in the case of the cost, so unknown rate, for example, is the cost, the rate of the cost is going to be dc dt, and at what level you want it. When they give you this one, they ask you to find it. Okay, when the production is 2000 flash drives, okay, the production is X, so when X is equal to the 2000. Okay, so this is the information that we have. Rate of the production is 6,000 units per week. For example, in this case, you want to find the rate of the cost when X is equal to the 2000. Okay, that's the step one. So you have to relate them together to be able to differentiate. Remember, there was something we call it related equation. Related equation. In the case of the cost, related equation is the cost equation. The cost equation is given to is the 5,000 plus 2x. So this would be the step for the cost function. I call it part one, because they give you part one for the cost, part B for the revenue, and part C for the profit. So the way we do it, we are going to differentiate this equation respect to the t. Okay, so you differentiate. You are going to differentiate. I just remind you, you don't have to write it down. You just do it. Plus 2x with respect to the time t. We are not going to say c prime because you differentiate respect to the t. So we say dc dt. dc dt is like c prime. So it's going to be equal to, the derivative of the 5,000 would be 0 because it's a number, plus 2 times what? 2 times the rate of the x. The derivative of x is 1. You have to multiply by the rate of the x. So it's going to be 2 times, okay, dx dt. dx dt. You see this formula that you have. You differentiate using the power rule, but you have to multiply by the rate of the variable. So derivative would be 2, but the rate would be dx dt. Okay, so you have a dc dt equal to the twice of the dx dt. Now you substitute. What do you have? You have that dx dt is 6,000, so this is going to be 2 times 6,000, which is given to you. Okay, and the result is going to be 12,000. So the rate of the cost dt dc dt is going to be $12,000. Okay, dollars is going to be 12,000. Okay, it's going to be 12,000 unit flash drive per week. So this is going to be the rate of the cost of the production. Any question? It's not a difficult problem, but you must understand, how to put it together to get these numbers. Okay, that would be useful when you are manufacturing or just running a business. It's very important for you to get this information. So we differentiate it, but since we differentiate respect to the t, we don't use the c prime. dc dt, dx dt, and then you substitute, you get your result. So that's the cost. Any question? We give you a couple of them, but we check all of them in this problem. The second part, you want to do it for the revenue. We do the same thing. You see the second part. You want to find the rate of the revenue. dr dt is missing. Okay. Again, the information is going to be the same. So you pick the function. The function is a revenue function. So in this case, the revenue is 10x minus 0.001x squared. Okay, so this is going to be your unknown. The known one is the one that you talk about it. The rate of the X is 6,000. So you differentiate again. Okay, differentiate. Differentiate this equation. 10x minus 0.001x squared, again, with respect to time t. Now for the r would be just the rate of the r. It's not r prime, we write it as a dr dt. That's the r. Over here, you differentiate first using the power rule. Derivative of a 10x is 10. You have to multiply by the rate of the x, dx dt. You see, anytime you differentiate, then you multiply by the rate of the x. Over here, use the power rule. It's going to be 2 times 0.001. So it's going to be minus 0.002x. That's a derivative. But you multiply by the rate of the x, dx dt. It's like a chain rule. And you have, or you always multiply by, okay? You multiply by u prime, if you like, to get these numbers. Question? Now substitute. What you have, remind you.
Excuse me, sorry, I
Yes.
thought the dx dt was the x, so you don't,
We
you have another,
differentiate first.
so you have another x
No.
instead of
You
it.
differentiate first, you see, derivative.
Mhm,
You're just using the power rule, remember?
mhm.
2 times 1 done. So that's
Okay.
going to be the derivative.
Oh,
But you
okay.
multiply by the rate all the time. Rate dx dt. You see this one? 10x. You
Mhm.
differentiate 10. You multiply by the rate of the x.
Oh,
You see this formula?
oh,
dy
yes.
dx is the derivative, but you have to
Mhm.
multiply by the rate, okay? So that
Oh,
gives you the
okay. Thank you.
Now, okay, so you substitute. What you have, I just remind you, from the first part, dx dt is given to is 6,000, remember? That's 6,000, and the x is, x was 2,000. Okay, now you substitute these two numbers to get the rate of the revenue. So dr dt is going to be equal to, you substitute 10 times dx dt times 6,000 minus 0.002, x is 2,000 times the rate is 6,000. Okay, 10 times 6,000 would be 60,000. Okay, that gives you 60,000. Over here, you multiply. 2 times 2 would be 4. Okay, that gives you 4,000. But you have 3 decimals, so that would be 4 only. You see, if you multiply these two together, that gives you 4 only. Now 4 times 6 would be 24. So that's going to be minus, okay, minus 24,000. Or you can check it with your calculator. Okay, if you subtract it, that give you what? It's going to be 0, 0, 0, and that's going to be 6, 3, $36,000. So the rate of the, okay, I write it down here. So the rate of the revenue is going to be dollars, $36,000. Again, it's a unit flash drive per week. So this is going to be, you know, if you increase the production, if you increase production by 6,000 units per week, this is the extra money that you're going to make. So you are going to make $36,000, you know, per week at this level of the production, which is a very good one. Okay, to get these numbers. Any question? So for the revenue, you got to be careful because you are going to have something like x and x squared. So you differentiate, then you multiply by the rate. You see, differentiate dx dt and just substitute to get the result. Okay, so that was the cost and the revenue. We just give you two of these. But the profit. For the profit, you have to find the profit function first. Okay, so we go for the part C. Okay, in part C, we want to find the rate of the profit. So that would be dp dt. This is missing. The given information is going to be the same thing. Level of production of a 6,000 and at x equal to the 2,000. You have to find the p first. Remember the profit function, you see, note that you have extra job. The profit function is going to be the revenue minus cost. Okay, so the difference between your revenue and your cost give you your profit. So you have to substitute to simplify to get this number. It's going to be equal to the R, the revenue function is a 10x minus 0.00001 x squared. That's the revenue minus cost. Open up the parentheses. Make sure you don't miss the sign. It's going to be 5,000. Okay, the 5,000 plus 2x. Okay, this is the revenue function that's given to you, and that's the cost function. Apply this negative sign carefully. So it's going to be 10x minus 0.001 x squared. Apply the negative sign, it's going to be minus 5,000 and minus 2x. Okay, minus 5,000 minus 2x. Then combine the like terms. So P, the profit, is going to be equal to, I start with the x squared, is a negative point. Okay, 0.001 x squared. Then I have the 10x and the 2x over here. So that give me a negative 8x. Negative 8x and minus 5,000. Just make sure to apply this negative sign twice to get this numbers. Okay, so this is the profit function. Profit function. Any question? Now you take the derivative of this one respect to the t. You differentiate it as usual using the power rule, but you have to multiply by the rate of the variables. Okay, so again, differentiate. Okay, differentiate with respect to the time t. So again, for the p would be the rate of the p, dp dt, equal to, for the rest, differentiate, multiply by the rate. So the power will give you negative 0.002x times the rate of the x, dx dt. See, that's the first one. The next one, the power rule that gives you just a negative 8 times rate of the x respect to the t. And over here, derivative of 5,000 would be 0. Any question? Now, a substitute, what you have? We have that the rate of the production dx dt is equal to the 6,000. And we have the fact that the x is 2,000. This was given to you right at the beginning, and you can use it for all of them. Okay, go back and substitute. So the rate of the p over the t is going to be equal to, that's it, negative 0.002x. Your x is 2,000. Okay, x 2,000 times the rate of the x times 6,000. Okay, that's it, minus 0.002x times dx dt. Minus 8 times the rate of the x, which is 6,000 again. Okay, 6,000. So simplify it, it's going to be equal to, you have a negative sign here, that's going to be negative. Again, you multiply these two together, that give you 4. Then 4 times 6 would be 24. So we get a 24,000. Okay, and where I get these negatives? That's the negative 2x. Yeah, I missed a sign here. You see, this is a positive 10 minus 2. That's going to be positive. So this is going to be positive 8 because this negative would be unusual. Okay, that was a 10 minus 2x is going to be positive 8. So I have a positive here and I have a positive here. Now that makes sense. I mean, it can be a negative profit. In that case, you're losing money. Okay, but not for this one. Okay, so that was a positive. So that give me positive here. So that give you 48,000. So negative 24,000 and 48,000, you subtract it. So that give you a positive 24,000. So you're making money. So the rate of the profit is going to be in dollars. So we get $24,000. 24,000, again, units per week or flash drive per week. So this means at that rate of the production that you did have, okay, so if you increase the production by 6,000 flash drives in week, so this is more money that you're going to make. You are going to make $24,000 per week. It's positive, so you're getting money, which is a good deal, if you like. Okay, that's it. This is the new topics. The rest are just the one that we cover on the quiz. So I grade your quiz and I post the solution of that quiz. You can compare them together, and you can do this. Those two application problem is there like the one that you did before. It's exactly the same one. And the problem of the implicit differentiation and the rest. If you have any question on those, you can email me. But study the one that we did tonight carefully. So this is going to be just one problem on the related rates. It's going to be very similar to this one, but this is too much, 3 functions. We may ask for 2 of these 3, but it's going to be the similar one. You just change it, the numbers really. So one problem on the related rates, one problem on the first derivative test. It may be, cubic on the fourth. You have the best one over here, so it's going to be 2. Okay, so for the relative max and the mean. Then you have one problem on absolute max, absolute mean. Okay, absolute maximum, absolute mean on the closed interval. And then you get one problem on the critical numbers, okay? So these are going to be 4. We may give you 5, but and the quiz make it to the 11, or we may give you 10 question, you answer 9, because it takes times to know to do it. Okay, that's it. Any question? So get those numbers, and if you have any question or any solution you want me to check, you can email me, I check it, any question, I can answer those numbers for you. And keep all of them, the one that we did tonight are going to be repeated on the final, okay? Because they are very important topics, okay? That's going to be the one. So that is, yes, it's a very good practice test, really. That is the way we're going to do it. Homework are not going to be due because we are going to have a test day. On the day of the test, we don't collect any assignment. So your next sets of assignment would be collected on the day of the quiz 2, which is going to be in 2 weeks' times. So there is going to be, I will post a take-home one for you to help you. Okay, that take-home one is going to be the model, okay, for